All right, welcome to a video discussing the unit circle. So remember, sine is opposite of hypotenuse, cosine is adjacent to hypotenuse, so katoa, we know this. Unit circle is a center at the origin with a radius of 1. So if you look at this triangle that's drawn within the circle, the hypotenuse, which is also the radius, is 1. We can call the horizontal leg x, the vertical leg y, as we naturally do for x and y coordinates. Now, if you think about it, x squared plus y squared equals 1 squared, or just 1. That's Pythagorean theorem. We know this. Now, also, if you think about it, if I put theta, my angle, at the base between the horizontal leg and the hypotenuse or the radius, I know that sine theta is going to be y over 1, or just simply y. That's true for a unit circle. Cosine theta will be x over 1, or just x. Again, that's true for a unit circle. As long as the radius is 1 or hypotenuse 1, we can do that. So we can label x comma y as cosine theta and sine theta. Now for tangent over a, that's y over x. Or remember y sine theta over cos theta. We call that a trigonometric identity because tangent theta is always identical to sine over cosine. Okay. So as we build the unit circle, remember, we always start at 0 degrees. We go counterclockwise. CCW for short is the positive direction. And we know as we go around, 90 degrees is a quarter turn, 180 half turn, 270 three-quarter turn, and finally we make a full circle, we get to 360. Label radius measures on the axes. That's kind of confusing. I think you label it on the circle, to be honest. I'm not sure why it says on the axes. Of course, this is x. This is y. But that's how we get started. And of course, 1 comma 0 is on the far right, negative 1 comma 0 on the far left, 0 comma negative 1 on the bottom, 0, 1 up top. Now remember, 180 is pi radians. We know this. If I cut my circle into fourths, so 0, 90, 180, 270, and back to 360, this would be 45, 135, 225, and 315. Just using proportional reasoning and simple math, we want to be in between those. And in radians, we'll do radians in blue. That'd be 0 or 2 pi. Pi over 2, therefore that's pi over 4. Pi, 3 pi over 4. 5 pi over 4. 3 pi over 2. And 7 pi over 4. And hence you get back to 2 pi, which is, or 8 pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And of course, we can reduce those if we need to. Now, if I draw a 45, 45, 90 triangle, remember the radius is 1. And the ratio goes as x root 2, x and x. So if 1 equals x root 2, then of course x is 1 over root 2, which will rationalize. If you rationalize the denominator by multiplying top and bottom by root 2, you get root 2 over 2. Because you get root 2 over root 4, which is root 2 over 2. So if you think about it, if that's root 2 over 2, and that's root 2 over 2, and that's 45 degrees, then no cosine 45 degrees is going to be root 2 over 2. That's just the x coordinate. The sine 45 degrees is going to be, that's 5, sorry. The sine 45 degrees is also root 2 over 2. Let me erase that, looks a little messy. And the tangent will just be 1, because you're comparing two sides that are identical. You're dividing two sides that are the same thing. Now remember, if we do move to different quadrants, remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If I'm in different quadrants, like let's say, for example, I'm 135 degrees, then this would be negative root 2 over 2 for the horizontal leg, but still positive root 2 over 2 for the vertical leg. And 1, of course, the hypotenuse never changes. Sine. So the sine of the hypotenuse is always positive, it's 1. In this case, my cosine would be negative root 2 over 2. So make sure you adjust the sign of whether it's positive or negative, depending on the quadrant you're in. Now if it breaks into thirds, again, 0, 60, 120, 180, 240, 300, and back to 360. I'll switch colors for radians. So 0 and 2 pi, that's pi. So we expect this to be pi over 3, 2 pi over 3, 4 pi over 3, and of course 5 pi over 3. Hope that makes sense for that one. And if you draw a 36-90 triangle, very simple. 60 degrees is right here. That's 1, 1/2, and root 3 root 2. Because remember, the ratio goes 2x, x, and x root 3. So if I do the sine of 60 degrees, that's my y coordinate, which is root 3 root 2. The cosine of 60 degrees, that's my x coordinate, that's 1/2. And my tangent of 60 degrees, which is y over x, or root 3 over 2 over 1/2, if you divide those fractions and flip the bottom fraction, you just get root 3. Breaking the 6 is a little more detailed. So 0, 180, 270, 90, back to 360. But that's going to be 30 degrees and 60, 120, 150, 210, 240, 270, 300, 330, and so forth. I'll go back to blue for radians. 0 and 2 pi, pi, pi over 2, 3 pi over 2. Now we're going in 6, so pi over 6. 2 pi over 6, which is pi over 3. 4 pi over 6, which is 2 pi over 3. Then 5 pi over 6. Then 6 pi over 6, which is pi. Then you have 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And finally 11 pi over 6, and then 12 pi over 6. So if I do this next, that's 1. That's root 3 over 2, and that's 1/2. So sine of 30 degrees, of course, is root 3 over 2. Sorry, 1/2. It's y coordinate, my bad. The cosine of 30 degrees, that's going to be root 3 over 2. And a tangent of 30 degrees is going to be y over x, 1/2 of root 3 over 2. You flip the bottom fraction. So you have 1/2 times 2 over root 3, 1 over root 3, so root 3 over 3. So the unit circle, which I do have filled out, let's see here. There you go, filled out unit circle, which everyone will have access to. But you may want to practice filling out yourself. And you can see all the coordinates on the unit circle correspond to all the different trig paths, like x for cosine, y for sine at those various angles that we just worked out. So it's really just using 36-90 ratios and proportional reasoning. Now, how do we use unit circle? We use it to evaluate trig functions at various places. Key things: know your location and know your coordinates. So for example, at 3 pi over 2, I want the cosine, I want the x coordinate at 3 pi over 2. That's, of course, 0. Negative 5 pi over 6. Now, if I go backwards, because it's negative, so I travel 5 pi over 6 in this direction. So 5 pi over 6 in the positive direction is over here, so naturally it'd be over here. And because it's sine, I want the y coordinate. That's going to be negative 1/2. Seven pi over 6 actually is going to end in the same place as negative 1/2. We actually call these coterminal. And we draw them either like this or like this. And we draw a terminal side that looks like that. 5 pi over 4. Going back to unit circle, that's going to be in the third quadrant. We're asked for the cosine. That's going to be the x coordinates, negative root 2 over 2. Sine of 8 pi. If you go around once, it's 2 pi, 4 pi, 6 pi, 8 pi. And back at the positive x-axis, the y-coordinate there is 0. And then 5 pi over 3, you want the x-coordinate 5 pi over 3, which is over here. You want the x-coordinate, which is 1/2, so we say 1/2, because that's for the cosine. So location and coordinates. And we can talk about reference angles, basically an acute angle formed between the terminal side and the x-axis. So you want the quickest way to get to that location. So 5 pi over 4, which I know if I convert that to degrees will be 225 degrees. So I expect to be over here. This refers to 45 degrees, which is why you can just look at the first quadrant, consider those coordinates and make an adjustment for whether x, y is positive or negative. Of course, x, y are both negative in the third quadrant, and then you could give the x coordinate if you want a cosine for that. So that concludes that video.